Good morning, all of you. My name is Deepa Bajetha. I am working as an associate professor in IIMT College of Pharmacy. Today, I am going to discuss about the topic is impurities and limit test. The content in this lecture is impurities in pharmaceutical substances, sources of impurities, types of impurities, effect of impurities, limit test, and last one is factor affecting limit test. So introduction about the impure chemical compound is what is impure compounds. So a compound is said to be impure if it is having a foreign matter, that is impurities. Any foreign particle present in a substance is said to be impure chemical compound. So what is pure chemical compound? A pure chemical compound refers to the compound which is having no foreign matter, that is impurities. Chemical purities means freedom from foreign matter. Analytically, 100% pure substance are not available and traces of impurities must be present. So what is impurity? Any material that affects the purity of the material of interest, that is impurity. Impurities means undesired particles, impurities means foreign particles. So presence of impurities in the pharmaceutical substances may produce toxic effect on the body and may also lower down the active strength of any pharmaceutical product. Impurities commonly in chemical substances include small quantities of like lead, arsenic, iron, chloride, and sulfate. Which type of impurities commonly found in medicinal preparations? So impurities which have toxic effect on body and bring about unpleasant reactions when present beyond certain limits, that is lead and arsenic salt. The impurities which are able to make substance incompatible with other substances. The impurities which, if present beyond the limit, affect the storage property of the pharmaceuticals. The impurities which are harmless, but if present beyond the limit, it will lower the active strength of the medicinal compound. Example, sodium salt in potassium salt. The impurities which may bring about technical difficulties in the use of the substances. Impurities such as taste, odor, color, or appearance, which can be easily detected by the senses and make the substance unhygienic and unaesthetic, is impurities. Example, sodium chloride becomes damp because of the presence of traces of magnesium salt. Also, phenolic impurities present in sodium salicylates alters its odor. So what are the main sources of impurities in the pharmaceutical substances? The type and amount of impurity present in the chemicals or pharmaceutical substances depends upon several factors like those listed below. These are the named sources of impurities in the pharmaceuticals. First one is raw material. The raw material which are used for the manufacturing of any pharmaceutical product. And second is reagents used for washing for the pharmaceutical project in manufacturing process. Method, which type of method or which type of process is used for the manufacturing any pharmaceutical product. Chemical process involved in the manufacture of the pharmaceuticals, and the atmospheric contamination during the manufacturing process. And sixth one is intermediate products in the manufacturing process. The product which will form intermediate defects in the manufacturing process. And manufacturing hazards, inadequate storage conditions, decomposition of the product during storage, accidental substitution or deliberate adulteration with superior or useless materials. So I will explain first raw materials employed in manufacture. Impurities known to be associated with these chemicals may be carried through the manufacturing process and contaminate the final product. For example, rock salt, calcium sulfate plus magnesium chloride is equal to NaCl. NaCl is prepared by the combination of calcium sulfate and magnesium chloride. We can also say NaCl is rock salt. A rock salt contains small amount of calcium sulfate and magnesium chloride. Thus, sodium chloride prepared from this source will contain traces of calcium and magnesium compound. So in NaCl, small amount of calcium and magnesium impurities is present. Another example is copper sulfate may be prepared by the action of sulfuric acid on copper turnings. Copper is combined with H2SO4 sulfuric acid. It will give copper sulfate, water and SO2. So copper turnings are known to have iron and arsenic as impurities. If large quantity of impurities are present in the raw material, they may enter the final product. Impurities are present in the raw material, they may enter the final product. Due to this, Indian Pharmacopoeia prescribes the limit of tolerance for arsenic as impurity to be not more than 8 parts per million in copper sulfate. Similarly, it prescribes a limit of iron as a impurity. Second is reagents used in the manufacturing process. If reagent used in the manufacturing process are not completely removed by washing, these may find entry into the final products. So proper washing of reagent is very important during the manufacturing of process. Example, ammoniated mercury may be prepared by the addition a solution of mercury chloride to dilute ammonia solution. The precipitate of ammoniated mercury, that is final product, contains ammonium hydroxide. Thus, this precipitate is washed with cold water to remove ammonium hydroxide. Soluble mercury chloride is combined with NH4OH. It will give ammoniated mercury. So this precipitate of ammoniated mercury is washed with cold water to remove ammonium hydroxide. If it is not removed completely by washing with water, the final product may contain ammonium hydroxide as a impurities. Next is method or the process used in the manufacture. Many drugs and chemicals, usually organic, are manufactured from different raw materials by using different method or process. Some impurities are incorporated into the materials during the manufacturing process. The type and amount of impurity present in the drug or chemicals varies. In certain drugs, a multiple step synthesis procedure is used which produce intermediate compound. Method or the process used in the manufacture. Usually side reactions occur during the synthesis. Impurities of the product, side reactions also occur in the substance. This may introduce new impurities due to contamination by reagents and solvent used through manufacturing process, and also various stages of the process. Thus, various stages of the process is reagent employed in the process, reagents added to remove other impurities, solvents are used, action of solvent and reagents on reaction vessels. First is reagents employed in the manufacturing process. Which are of reagents are used for the manufacturing process? First one is soluble alkali in calcium carbonate arises from sodium carbonate used in the process. Calcium carbonate is obtained by interaction of soluble calcium salt and soluble carbonate, and therefore the product will contain traces of soluble alkali which the washing process has failed to remove. Second one is reagents added to remove other impurities. Reagents are used for the manufacturing process. Reagents are used for the removing impurities. So potassium bromide contains traces of barium which is added in the manufacturing process to remove excess of sulfate. Water. Water is the cheapest solvent available in market and has been used wherever possible. There are type of solvents which are used. First is softened water, demineralized water, distilled water, tap water. So tap water has calcium, magnesium, sodium, chloride, sulfate as impurities in a small amounts. But in softened water, it is obtained by allowing the tap water to pass through the sodium form of zeolite, which removes divalent cations like calcium, magnesium from tap water in exchange of sodium. Second is demineralized water. It is obtained by passing tap water through columns. You can see columns in this diagram. Tap water through columns packed with ion exchange resin. The water obtained from this process is free from these ions. Distilled water, it is considered the best, but it is very costly. Distilled water is best solvent for use in the manufacturing process, but sometimes it very costly. Action of solvent and reagents on the reactions vessel. So what is the action of solvent and reagents on reactions vessels? During manufacturing process, some of the solvents and reagent may undergo reaction with metals of the reaction vessel. The metal which are used for the manufacturing of any container in which we prepare drug. Example, iron is known to contain arsenic impurity. Chemical process used in the manufacture. For the synthesis of drugs, many chemical reactions such as nitration, halogenation, oxidation, reduction, hydrolysis are involved. Tap water is generally used in various processes and is often having chloride, magnesium, calcium ions, which are generally found in the substance which is being manufactured. What are the atmospheric contamination during the manufacturing process? In the industrial area, the atmosphere is contaminated with dust particles and some gases like hydrogen sulfide, sulfur dioxide, and black smoke. During the manufacture or purification of the pharmaceutical product, these impurities enter the final product. There are many pharmaceutical products which, when manufactured or contaminated with atmospheric CO2 and water vapor, example, sodium hydroxide absorb atmospheric CO2. When we NaH treated with CO2, it gives sodium carbonate and water vapor. Atmospheric contamination during the manufacturing process. Due to this reaction, sodium hydroxide should not be kept open for a longer time during its manufacture. Therefore, IP has prescribed that sodium hydroxide should not contain more than 3% of sodium carbonate. Next is defects in the manufacturing process. In many manufacturing process, there are defects like imperfect mixing, incompetence, non-adherence to proper temperature, pressure, pH, or reaction conditions, which may give chemical compounds with impurities in them. Example, zinc oxide may be prepared by heating metallic zinc to bright redness in a current of air. The vapors of zinc burn to form zinc oxide, which is collected as a fine white powder. Next is intermediate products in the manufacturing process. There are some intermediates which are produced during the manufacturing process. Sometimes these intermediates may be carried through the final product as a impurity. For example, potassium iodide is prepared by reacting iodine with potassium hydroxide. Next is manufacturing hazards. Manufacturing hazards are particulate contamination, process errors, cross contamination, microbial contamination, and packing errors. These all are manufacturing hazards. So first one is particulate contamination. In particulate contamination, the presence of unwanted particulate matter can arise due to dirt, dust, glass, porcelain, or plastic fragments from sieves, granulating or tableting machines, or from product containers. This unwanted particulate matter will come from this tableting machines, sieves, or granulating and from product containers. Wear and tear of equipment or improperly cleaned equipment may also cause particulate contaminations. Clarity of solutions for injection is particularly important. Example, metal particles which have been found in eye ointments packed in a metal tubes. Process errors. Gross errors arising from incomplete solution of a solute in a liquid preparations must be detected readily by the normal analytical control procedures. Minor errors arise if the manufacturing tolerance for the quantity of active ingredient in the product has been wide. Next is cross-contamination. The handling of powders, granules, and tablets in large bulk creates airborne dust, which leads to cross-contamination of the product. So face masks and special extraction equipments are used to protect operators from harmful effect of drugs. Example, penicillin preparations require special handling during its manufacture. So cross contamination is contaminates from environment and operators and contaminates from equipment, product from the environment and operators and product from the equipment. Microbial contaminations. Parental preparations and ophthalmic preparations require special care against microbial contamination. Many liquid preparations and creams are liable to bacterial and fungal contamination, so care should be taken. Packaging errors. So packaging errors is also important point in impurities. Product of similar appearance such as tablet of same size, same shape, color, packed in similar containers can constitute a potential source of danger. So improper labeling or destruction of stock of unused labels also constitute a major packaging hazards. Storage conditions. The chemical substance, when prepared, have to be stored in different type of containers depending upon nature of the material, batch size, quantity. Many type of materials are used for storage purpose like plastic, polythene, iron, vessels, stainless steels, and aluminum. The reaction of these substances with material of storage vessels, the product formed are found as impurities in the stored materials. Next is decomposition of the product during storage. Chemical decomposition, analysis, or breakdown is the separation of a chemical compound into elements or simpler compounds. It is sometimes defined as the exact opposite of a chemical synthesis. Chemical decomposition is often an undesired chemical reaction. Delinquent substances absorb water from the atmosphere and get liquefied. Decomposed product appear as impurities in the substance. You can see in this diagram is pellets of sodium hydroxide are delinquent. For this region, containers of NaOH should always be tightly stoppered. The solution formed by a delinquent substances a lower vapor pressure than that of the water in the air. The impurities present in the substance may give following effects. So impurity, if any impurity present in the pharmaceutical substances having toxic effect and may be injurious to the health, if present above its certain limits, the traces of impurities may exert a cumulative toxic effect after a certain time. Impurities may lower the active strength of the substances. Impurities may decrease shelf life of a substance. Impurities may cause incompatibility with other substance. Impurities may cause a physical or chemical change in the properties of the substance, so making the substance medicinally useless. May cause change in color, odor, and taste for the presence of impurities. So what are the tests for purity? The pharmacopoeia prescribes the test for purity for the pharmaceutical substance to check their freedom from the undesired particles, foreign particles. Pharmacopoeia will decide and fix the limit of tolerance for these impurities. So test for purity for certain common impurities for which pharmacopoeia prescribes. The test for purity are color, odor, taste, physiochemical constant, iodine value, saponification value, melting point, refractive index. These all are the physiochemical constants, acidity, alkalinity, pH, humidity, cations and anions, ash, arsenic or lead, loss on drying and loss on ignition. These all are the tests for purities. So limit test. Limit test is used for to identify and control the small quantities of impurities which are present in the pharmaceutical substances. So limit test is test being used to identify the impurity. The test which are used to control the impurity is called limit test. Limit tests are the quantitative or semi-quantitative tests designed to identify and control small quantities of impurity present in the pharmaceutical substances. Limit test will be performed in lab in the Nestler cylinder. Factor affecting limit test are specificity of the test, sensitivity, control of personal errors, test in which there is no visible reactions, comparison methods, and quantitative determination. These all are the factors affecting limit test. If any impurity present in the limit test, it will be appear as a turbidity. Turbidity means cloudiness or haziness. Thank you.